I'm Ben Johnson and I work at this place here, and this is Schmiedman Suomi Oy, Osaki Yhtiö in Finnish, and that basically means a limited company. And I've been working here for just shy of 5 years in April next year. Why do I work here? Well, before that I worked at a BMW main dealer, and that was pretty good. Did a lot of warranty work, easy money, good bonus, but boring. Didn't have the chance to develop things any further there. Obviously, when you have a problem on a car at a main dealer, you just change the part once you can prove that that part's faulty. Here at Schmiedman, I tend to actually strip things down and repair them, even replace circuit board components such as diodes and resistors and all sorts, transistors, all sorts of things like that. Where did I start? Well, I started in '96 at Foxfield Rover in Wigan, and sadly it doesn't exist anymore. So I graduated from Pagefield, Wigan, Pagefield Technology Campus many years ago. I had a lot of good lecturers there. They were basically all old mechanics. Bob was one of them, I forget his name. Ken Morris was the main guy there. I don't think they're probably still around anymore, sadly, and if they're not, it's a shame. They were fantastic people, but this was 30 years ago, and those guys were already in the 50s and 60s, I think, a lot of them. So yeah, I learned a lot there, really. I learned from a lot of old school mechanics. Don't forget, when I was at college in 1996, or actually I started in 93, when I was there between 93 and 96, a lot of these old mechanic sort of people, they were like born in the 1920s, some of them. So they had some stuff and some techniques that you'll not hear about anymore. How to ream kingpins out. Who remembers doing that? Reaming kingpin bushes out and having put new ones in and stuff like that. You ask young people nowadays, they don't have a clue even what a kingpin is. So the reason I'm mentioning all this and digressing from the topic of this video slightly is because those people and those experiences, what they give me, which are now dying out, people like Fred Dibner, they were people like that, really. I feel very blessed because if I go to college nowadays, I won't get anyone who knows them skills. So they're the people who really made me think the way I think, and then all the other people I've met over the years have contributed to me being a very good fault finder. Or so people say. I don't want to be arrogant about it, but I'm pretty good at finding most things that are put in front of me. After that, I spent time as a master tech with Nissan for many years. Did a stint on Peugeot, Kia. I've basically worked on most brands. Decided to move away from the UK in 2013, January. Why did I move? Salary was disgraceful in the pittance, and if you're watching this and you own a company or you're a decision maker in terms of salaries, I just want to come away from the video slightly and just explain to you that if you're not paying a mechanic £1,000 a week in the UK, you're very foolish, because if you don't do that, you're already running out of people to work in these jobs. The skill pool is shortened to the point where it's critical, not just in England but across Europe, Finland in particular. And in Finland they are still not paying the best, but they are paying over £1,000 a week for really good people. So if you're not doing that, do it, because you're going to be in even more trouble than you are now if you don't do that. Everyone deserves a very good salary if they're good at this job, because it's extremely difficult and the job's getting more difficult as cars and technologies evolve to become ever more difficult, ever more complex. So I can imagine many of you are probably wondering, and rightly so, why I moved to Finland and what was the reason behind it. Well, the salaries in the UK were terrible, but also the working conditions were not really what I wanted. So I made the decision to move, and I moved in 2013, as you know. And what was I doing there? You might want to know that. Well, actually, I was basically test driving cars for Mercedes-Benz, Audi and Volkswagen in a top secret test location in a mountain near Monio. And that's near the Levy Ski Resort, which is quite famous. A lot of Brits are going there to see Father Christmas in the winter time, Christmas time. So that's where I lived. And I loved the job. It was the most fantastic job I ever had. Salary was quite reasonable, and I spent all day driving around top secret test tracks. Kind of like Top Gear Challenge, really, taking cars sideways on lakes around cones and stuff, and various handling circuits there. It was a fantastic job. However, in April 2020, with it being a seasonal winter job, there was no work. So I decided to send out some CVs. Got offered only one job, which was in the southeast near the Russian border in Lappeenranta for Lappeenranta and Autotech. I ended up spending a couple of years with those guys until in 2015 I got headhunted by quite a new BMW dealers, which is now part of Heading Automotive. And at that time, it was fantastic because it was quite a new deal. I think it was around 1.5 years old. So everything was brand new and fantastic. Even had soundproofing on the ceiling, so there was no noise in the workshop. It was brilliant. Best place I ever worked in that sense, for terms of comfort. After that, I went to Schmiedman in 2020. because I wanted to live in the Helsinki area. And that, as they say, is how it ended up. And my passion, basically, is to teach people and to push my knowledge on what I've got, because there's nothing worse than keeping it to yourself. And that brings us on to the topic of this video. This video is a presentation about a GO1, and this one was a 2020 GO1. Now, let's look at that. It's 4-year-old. It's a bit disgraceful what happened to this car, and apparently it's a fault that's quite common. Now, if I'd have known that several weeks before I started, messing around with it, it could have saved myself a lot of pain and hassle.
This is a GO1 X3, and this car almost made me want to quit my job. It was one of the worst jobs I've ever done in about 10 years of doing this, of sort of fault finding on BMW in Finland. And I've got 30 years in the job, fault finding about 20 of those years. It was literally the worst job I've ever done. I tried to get help off technical support at BMW and they kind of didn't really help me.
But you don't learn, do you? If someone says just, this is the location of the fault, you can fix it very fast, but you're not going to learn anything. It's much better to actually take a fault you don't know anything about and then arrive at the same conclusion as the factory engineers obviously have done, but didn't bother putting a technical bulletin out about it, because there is no technical bulletins for this problem. However, when you speak to BMW dealer master technicians at BMW, which I did after the fault was cured, after I did a LinkedIn post, they said, oh yeah, it's quite a common fault, that, not just on the X3, but also on 5 Series G30s and stuff like that. I asked for help with this job, which I'm going to get into in a minute, from MSX International, which is handling jobs on behalf of BMW Nordic, and the customer service was nothing short of disgraceful. Not only did they not help me, they actually ignored me and they closed the case without even bothering to provide any help, not even a hello or anything like that, and we paid for that. I emailed them, I got no comeback. I spoke to one guy, and basically they're not interested. Very poor customer service. So with BMW or MSX International, the whole BMW group not backing me up and not helping me, I was on my own. I don't have anyone else to ask. Who do I ask? Well, I use my skills, what I've learned over the years, which I'm going to teach people, because they're good skills to get to the bottom of this problem. So what was it? Well, guy complained about this check control message. So as you can see, it's a warning for the cooling fan. It's in Finnish language, and that just basically means the cooling fan isn't working. It's not working at all. Bit of a problem. So the situation was quite simple. The guy brought it in. One of them people, oh, I need it back in 2 hours. And it went on like this for several weeks. That's how many fault codes there was. Never seen this fault before. Guy wouldn't leave the car. And eventually I said, listen, if you want this car fixing, you're going to have to leave this car with me for 1 week. Then we found the fault. It didn't take me a week, but I was able to go on and off the job as I did my other jobs. 1 hour here, 2 hours there. But the car was stripped and it was in the workshop ready. This was a challenging job because you've got so many fault codes, and usually you can take out a couple of the main fault codes that are present and you can work out that these others are consequential faults. Well, in this case, it wasn't really that simple because they were almost all present at the same time. And in the end, it was one simple clue that I just missed, because you do miss things, don't you? And that one clue put me and steered me on the right direction. So, first of all, when the car was breaking down at the side of the road, he was then able to not start the combustion engine. He was unable to start the combustion engine. What he was able to do, though, was he was able to drive home on his high voltage battery, because he knew there was a fault on this car. So what he'd done, he'd switched off the electric only option in the hybrid drive, and he was just using combustion engine. But I think he was also using it where it actually is charging the high voltage battery as he drives, which was a smart decision, because when the combustion engine just basically died because the voltage was dropping, he was able to limp home. That was a clue. But back then everything was so confusing, I didn't really know, like, I couldn't join them dots together, the jigsaw puzzle wasn't like sort of built and joined together. I was looking at so much live data, I even said, listen, we need to get another X3. So we got another X3. It wasn't an hybrid. It was just a normal petrol-engined X3.
So I'll show you in a minute what I'm actually doing, and I've found the fault. Basically, this isn't a hybrid, which is a bit of a shame. I wish I had a hybrid to compare it. but there's a spike on the BDC essentially when it goes to ground. So I'll show you now what the situation is. But this could be the reason for most of the problems. Let's just see what happens. This is why you need other cars for comparison. You contact tech support, close the case, you don't even bother having the decency to help me. I just don't understand what's going on. I don't work for a dealer, but we're paying for it. I pay, you know, we pay a lot of money every month to be on the after sales online system. And when you submit a request that you're paying for and they just close it, and I've emailed, promised they'd look into it, nobody gets back to me, I'm on my own. Without a car to compare it against, I'm screwed really. Nowhere in BMW does it tell you that you should see 0 volts here, 5 volts here. Definitely that's the reason why there's a fault code.
I got a lot of live data on the Think tool, and I got a lot of live data such as this particular thing here. Now, what I'm showing you on the screen there is a screenshot of the key on and key off battery voltage. And this, after I'd done a lot of messing around and, you know, swapping components, this was a clue for me because I thought, well, this is a non-hybrid, but it's the same architecture. And what this is showing on the good car a drop to 0 volts with the key off. That's what you should see, isn't it? And on this one, on our suspect car, we've got a drop and it goes randomly like in a sort of sawtooth pattern. 3 volts, 2 volts, 3 volts, that type of thing. Well, it doesn't drop to 0 volts. Why does it not drop to 0? Well, this was the reason for the fault, you see. And basically, it led me down the wrong sort of route, really, if you like. The fault code, the main fault code that I could work out on this particular vehicle was this particular fault code here. And what this fault code pointed to was a short circuit on the line from the body domain control at the front right of the vehicle to the LIN switching box at the back of the vehicle, which is actually built into the rear electronic fuse box. And this particular line is a power supply for the LIN box, so without that, the LIN box is dead, it won't be powered, it can't do any switching. And I worked out that this line, it was complaining this line was dead. The circuit I'm focusing on is very simple and stripped down because this is really all we were dealing with. We've got an engine ECU DME, we've got a body module and gateway module in one integrated, which is a body domain controller. And we have a rear fuse box, which is a dumb fuse box, relays and fuses only. And the fuse box at the rear is actually interestingly actuated by something called a LIN distribution box, a very small important box that plugs into the rear fuse box. How is it controlled? Well, simple. It's controlled on a line called LIN SV, you see it there, and it's controlled from the BDC as the master, and of course the LIN distribution box is the slave. So, why did I choose to focus on this part of the car? Well, with a lot of trial and error, and remember there's so many fault codes, I found that the choppiness of the voltage hanging around on the ground, the 3 volts, was coming from this point here, so-called 15.1, which is the power supply to the LIN box from the BDC. And I noticed that I always had a perfect voltage of 14 volts from the DC-DC converter. And I could never understand why I had this global undervoltage system and why certain components such as the Valvetronic motor was showing less than 9 volts and why the engine ECU was showing less than 9 volts. It sounds simple now, but remember that when you're in a garage and you've got multiple jobs at once and you've never seen this particular fault before, it can be quite overwhelming at times to get your head around what's actually going on. So the global undervoltage is the most important thing because actually I found that by disconnecting terminal 15.3 from the BDC, which is the power supply to the DME, I actually noticed that I had 0 volts with the key on and off at terminal 15.1, which was the power supply to the LIN distribution box. And then I was able to erase that fault code. The only thing that remained to see was why I had this strange 3 volts, which was now clearly coming from the DME because it was disconnected from the BDC. So there was something on the DME causing this issue. 15.3 and 15.1, they're basically the same circuit. They're actually soldered together inside the BDC, so they're completely indistinguishable from each other. At this point I decided to put a Schottky diode in, with minimal voltage drop and a good forward voltage of around 13.7 volts. It actually worked in the sense that once the diode was soldered in to this 15.3 line, it was then clicked back into the BDC. I had this 3 volts with the key off, but I had 0 volts after it. The diode was doing its job and blocking the voltage, so of course the live data then showed 0 volts instead of the 3 volts. So I thought I'd cracked it, but I hadn't quite cracked it. but I knew it was something on the DME. So let's carry on with this troubleshooting and let's tie it off and, you know, let's find out exactly what the issue was.
So I've come to Parkco basically because I need to get this dialed and hopefully fix this problem. In case you're wondering, this is Tikkurila. This is where they make the famous Tikkurila paint. Just a bit of interesting shaboola there for you. So I'll go in here. I probably won't film because they don't kind of like that, but yeah, that's where I am. Good old Parkco. So let's hope that we've got this. It costs, I think, let's have a look, 62 cents. Cool, huh? It's like a sweet shop. You always want to buy everything when you come in here, isn't it? Anyway, let's get this. Let's see how we go. Well, I got them. I got the old diodes. So what I'll do, it's a bit busy in there, and I didn't really fancy started breaking out the fluke meter. So basically, I brought the fluke meter with me because it's like about 6 miles away, 10 kilometers is that roughly. So what I'll do, I'll just give it a quick measure, because the reason I got a Schottky diode, a bit big these actually, but they're absolutely heavy duty. They'll do the job for that little power supply. I got the Schottkys because they've got a very low voltage drop, as I said. Normal diode won't work. There's just too much resistance in them. It'll drop the voltage down to from 12 to 4. So I'm hoping this will drop the voltage only down by about 0.3.
So it goes without saying, if your limb box is dead, you're not going to have any output to your rear fuse box. And that was essentially what was happening. I thought I'd cracked it. Let's take a look at the fault codes again. There's a huge volume of fault codes. But if you look at the fault codes for the engine ECU, the DME, there's a lot, isn't there? And it all seems to be pointing to the fact that there's no battery voltage. Now, that was another clue, because it seems the majority of the fault codes are related to things like the Valvetronic has no power and all that type of stuff, cooling fan. But they all seem to be pointing to the DME. Now, I never picked this up at first. I don't know why I didn't pick this up. The DME has various power supplies going to it. But it's sad, I need to focus on this now, because why am I losing battery voltage, but yet there's no, the system voltage from the DC-DC converter from the electrical machine electronics is banging on. There's nothing wrong with it. I missed this. I missed it. I was starting to focus on why have I got this strange 3 volt sawtooth pattern, and why don't I have a 0 volt drop off. That's the DME basically, and that's the battery voltage, but the whole vehicle is 14.5 with battery support on, and I can show you that. There. That's the problem, and as you'll see, it's a bad ground. And I worked out that what was happening was there was something wrong with this wire here, this grey one. It was going to the engine ECU, and then it was in turn causing a problem on the yellow wire, and that's why it was saying there was a short on that line, because it was seeing 3 volts and not 0 volts. So the BDC was reporting a short, and it was switching it off the feed. But the real culprit wasn't the LIN box, it wasn't the fuse box at the back, it wasn't this yellow wire, it was the grey wire. The grey wire that powers the engine ECU. So, where's the problem? Well, what I did, I just got the power probe and I whacked a ground on it. And when I whacked a ground on it, I had no 3 volts. I had everything was bang on. I had no issues at all with anything. I could erase all the fault codes. But that comes on to the other thing. This car was like, before I started to get like guts deep into testing it, essentially, there was no fault codes once you erased it. And it were kind of, it seemed a bit random. But lo and behold, once I actually had worked out that we had a bad ground, didn't find out where the ground location was at this point, all I had to do then was look at the DME live data, and it escaped me. I don't know how I missed this one, and it was like 10 odd volts. It went as low as 9.8 volts at one point, and it's like that because you've got this voltage drop. You've got a bad ground at the ECU, and if you've got a bad ground at ECU, you're going to have a problem with your voltage as well, because the ECU ain't going to be powered right, is it, if you've got resistance on the ground? So I'd kind of found the fault, which was fantastic, because it weren't so easy. I got no help off anyone, and I'm quite proud of myself that I managed to find it all in the middle of doing like 10 other jobs at once on different cars, because that's just how it is. When you're fault finding, you just jump in off from job to job. It's not like you don't have a luxury to just sit there all day long with an oscilloscope and start messing about, because you're not going to get paid for it. You're not going to get paid if you don't find faults fast. You're not going to earn any money in this job, and that's the issue. That's why I'm not into all this fancy stuff like, oh, let's scope it and let's have a cup of coffee and let's have a discussion. It don't work like that in the real world. In the real world, you've got a problem, you've got 10 other jobs backing up behind it, and if you don't get this one done fast, you're in trouble. So, missed that one. Put my power probe on. Now I've got 14 volts at the engine ECU when I power the ground up in live data. And that's why we were having that weird signal trace when we used the think tool, live data. Same when I put the scope on. I even put the scope on. I'll show you that on screen. I put the scope on at the same time just to make sure my live data was kosher, and it was. So basically I knew there was an issue there. Now, I want to just tell you something before I found this ground problem. I tried cheat a bit. I put a Schottky diode on. And what the reason I put a Schottky diode on is, well, basically a Schottky diode. What is it? Well, a Schottky diode is a diode, so it only allows current to flow in one direction, and it won't allow it to flow in a different direction. So if you put it on the correct way, in the the direction of current flow, so that will be, I put it on the BDC, flowing current from the BDC power supply on the grey wire to the DME, but the 3 volts at the DME, because of the background, could not flow back. And yeah, it worked a treat. It was fantastic. It was brilliant. I had virtually no voltage drop either. 14 volt DC-DC converter power supply, I had a drop of half a volt, 13.5 or 13.6. That's more than acceptable. It's not going to cause any problems. When I put a normal diode on, I had a drop, something like 7 volt drop. There was like 5 volts or something going to the engine ECU, the DME. So that was no good. So I bought a Schottky diode. It cost about 80 cents on Partco. So the reason I did that was to block this errant 3 volts coming back. And that kind of worked too. That actually stopped me having fault codes on the Lin SV line, which was the main fault that was driving me mad for ages, working out why it was there. But of course, I still had a bad ground at the engine ECU. And because I had a bad ground, I still had problems then with the Valvetronic failing, and basically ultimately the engine just dying out, because it just wasn't, it's kind of like when you have an alternator or a DC-DC converter failure, it was the same symptom. So eventually you'll get to 9.5 volts. Critical voltage, it'll just cut off, because the system can't function beyond 9.5 volts or 9 volts roundabout. It won't work. That's your minimum voltage cut off. I think maximum is 15 or 16 volts. And in those in that parameter, either way, it'll just cut off. So then I decided, well, I'm going to find this bad ground. So what I did in the end was I found it. It was at the back of the engine, and I could see it, but I couldn't get to it. It was a nightmare. So just to test our theory, what I decided to do was I just cut off 4 wires, and I made a fantastic harness. I was quite happy with it. It was great. And I put it at the front of the engine in a more sensible location, not a stupid location at the back of the engine. Guy went on his merry way, and he drove about 1,000 kilometres over a month, in a month's period, and he had no problems whatsoever. However, the car had an aftermarket warranty. It was deemed necessary that we would have to actually put a new harness on, really. Retrofit it kind of thing, because when I say retrofit, I mean trying to do it without taking the engine out, which was extremely challenging, let me tell you. So that's what we did. We ended up actually pulling the harness out and replacing it. Hell of a job it was, really. But the guy was made up because he actually fixed the problem. As you can see on the screen there,
we've got a problem with the DME voltage. It's saying that it's only essentially 10.5 volts. And what's happening with this X3 hybrid? It's dying because there's not enough voltage power or anything. But as you can see, there's 6 power supplies there and they're all 14 volts. So you would think there's a fault inside there. But the video I did yesterday, if you remember, about voltage drop, we don't need to load this. We've got 3 ground. Ground is a power supply. Just get that in your head. A ground is a power supply. These are all on the same ground point. Check this out. You're going to absolutely wet your pants. That there is a fault finder's wet dream. You've got 4 volts on the ground. What does it mean? So this job here is this X3. I put a Schottky diode on the BDC and that stopped the back feeding from the DME into the BDC, which was causing the limb box to fail at the back, causing the fuse box to fail. 2 pages of fault codes. Now I've just realised when it says global undervoltage, it doesn't mean the battery voltage in the car, it doesn't mean the auxiliary battery. What it means, the DME don't have enough voltage. We've got 14 volts everywhere in the car, but DME 10.5 volts. Just measured it, 14.5 volts input. No problem. Ground's 4 volts, got bad ground on it. 10.5 plus 4 is 14.5. Bad ground, that's all it is. 2 pages of faults, bad ground. Let's see if we can find the problem exactly. You can just see there, that's the ground at the back of the engine, and it's melted. You can hear my voice there. It's melted there, that's definitely melted. So that's a nightmare, and it's basically on this GR1. It's right down the back. Quite a lot of things are connected to it, so it's always tempting to chop these off now and just make a new ground. But your danger of doing that is that if there's anything else at the back of that engine connected to that ground, some other ancillary component, and you still haven't fixed the problem. You fixed that, but you haven't fixed the main problem, right? So we need to work out really. It's only them 3 wires. I'll just chop them and I'll make a new one and I'll join it to the engine again rather than the body, with it being a hybrid. So because the GR1's the worst car ever made in my opinion, I've had to make my own ground. Now don't hang me out to dry. The reason I've made it, and it's quite a thick one by the way, the reason I've had to do it is the actual ground, what's dodgy, what's burned as you've seen, is down the back. Now I just went under the car and I'll show you that in a minute. There's no way I'll be able to get my hand on it and to unpeel it from the harness as well. And it actually powers the high voltage compressor and the water pump here. It might not be that water pump actually. If that's the turbo pump, there's another one, could be that one, might be that one, I'm not sure, I'd have to look at wiring diagram. But essentially, there's no way I can get my hand on it. So as you can see guys and girls, that's exactly why I've done that wiring bypass, because up there, and don't worry, it is de-energised, I can't get to it because it's just, I'd have to take the gearbox out, and it being a hybrid, it'd be a pain in the bottom to do that. So the idea is I'm not going to chop the wires, I'm just going to splice, and what I'm going to do is I'm going to solder these tails in, over the original wire and leaving everything still connected, and it'll use a different ground then, so in theory it'll fix the problem. Well guys and girls, it's funny, I never noticed it before, but the water pump you can hear is now circulating on the turbocharger. So what I've done, I've made a new wire all the way into there. I've used 4 separate strands to give it a huge amount of current carrying capacity, and I've just sort of tapped them in and soldered them into the existing wires without cutting them. As you can see now, we don't have any voltage drop, we have perfect ground. You should have 14 volts. There we are, so it's now fixed, isn't it? You've got perfect ground. And that's why we only had 10 volts before, because we had no ground, or we had a bad ground. Well guys and gals, I'm so happy to see that. Battery voltage finally in the DME. A little bit more than what's on the car. So yeah, I'm dead happy with that. I'm made up actually, to be honest. So here's the engine bay, and I'm actually up in here. There you go, see? Because I'm kind of got the gearbox loose, and it's basically down the back of there, and I will show you that in a minute. You've got to strip so much just to get this harness up and out, and that's what I'll show you. But first of all, let's take a look at the old harness I've took out and the bit I made. Basically, as I've just cut there, I've cut it off now, I don't need them anymore. That was a temporary ground, and it fixed the problem, and it went from there to the DME. So this is where it is, the ground at the back of the engine. It's a goddamn pig to get to. Take the transfer box out, loosen the gearbox, mounted at least, the transfer box, just to drop it down a bit and then jack it back up again. And actually the gearbox is now jacked right the way up now, touching the tunnel, so that it'll bring the engine forward, so I've just got enough room, you know. But actually doing this, oh man, it's a big job. Kind of a big job. It took me about 4 or 5 hours so far, but it'll take me a lot longer to build it up, it always does.
So the job was finished at the end, and guy was happy, more than made up. And as you can see there, that's the bolt of doom, as I call it. That's the one bolt at the back of the engine, Torx bolt, which was very difficult to get to, and it involved essentially removing the transfer box off the back, purely for access, and jacking the gearbox up until it touched the tunnel, because I had to remove the wiring harness, and of course I had to remove the gearbox. Transmission wiring harness comes with the new engine wiring harness. The reason we did that was because there's a warranty on it, aftermarket warranty, and it was actually the warranty company who insisted, yeah, let's just put an harness on it, because they don't normally do that. They normally try and shy out of paying for anything. But in this case, guy was saying, oh, I want a new harness, and all that. And then they just agreed. So that's what I had to do. And there's another shot of it there on the cupboard in my shelf area where I keep all my wiring. So I've got some useful wiring connectors there now, which I've used for other jobs since then, because there's nothing wrong with them, really, is it? It's just a bad ground. And as you could see at some point in the video, you noticed on the DME, the ground wires were they did look a bit burned. They'd been a bit hot then, because it'd been drawing so much current, because the ground was terrible on it. Such a bad ground point. And it's a bad ground point on back engine, isn't it? Let's be honest, it's not the best. What would I like to have done different on this job? I would like to have, if there had been some sort of technical bulletin, or if I'd have been asked someone else before I did the job, and then I get everyone chirping and saying, oh yeah, it's a common fault that. Well, I've known that before. I could have saved myself a lot of hassle. I would have loved to have had a bit more info about it, a bit more info online, a bit more info on Google and all that. Found nothing, no bulletin that I could see, no tech bulletin or anything like that. What I was most unhappy with was in my opinion, the fault code itself, the fault code reporting. Because to me, the one that I didn't really focus on as much as I should, the global undervoltage one. What does it even mean, global undervoltage? The fault really was a bad ground at the engine ECU. When you have a power supply problem at the DME, there's a fault code usually. No, there is. I don't say usually. There's always a fault code. And usually it'll say DME power supply. For example, on BMWs, when you have an integrated supply module, they have kind of built-in fuses. They can be changed. You're not supposed to, but they can be. When they blow for whatever reason, let's say you have a bad injector or a bad coil that blows them, you don't have any power at your DME, and you get a fault code, and it tells you, and you know what to look for. However, in this case, when you've got a bad ground, it don't even mention it, does it? It doesn't mention it, really. At some point in the global undervoltage test plan, I think it does actually mention to check a ground. But it's not very specific, is it? I mean, it should actually, there should be a specific, proper fault code that says there is a voltage supply problem at the DME. But it doesn't. What happens is the test plans they never factored in that what could happen is you could have a bad ground. You could have an errant 3 volts trying to find a ground path, because it can't, it can't get back to where it needs to get to, because there's a blockage, there's a bad ground. It doesn't conduct properly pole to pole. So you've got this potential difference problem on this car, and this voltage, ground star voltage, the negative electrons, they can't go to where they need to go. So then they find a path of least resistance, which in this case happened to be the body domain controller, back through the DME and then back into the body domain controller. And that was a massive problem, because that then caused kind of a short to ground, if you like, on the line 15.3, the power supply for the DME. And it then caused the same sort of short on the line 15.1, which was the power supply to the limb box, purely because they're on the same circuit in the BDC. And that in turn then triggered an issue on the LIN line, saying that there was an issue with the LIN line, because they could dare say that was shorted as well. It's just a very strange job, really. And I dare say some of you lot, you're watching this, you're probably thinking, oh, I could have done that in about 10 minutes, that. And maybe you could have done, and if you are, then you're the best fault finder in the world in that sense. I can do things in 10 minutes. I can do a lot of things in 10 minutes, these so-called complicated jobs. But every now and then you get one like this, it comes along, and it's just a bit more challenging, because like I said, there was probably about 100 fault codes. I think I didn't count them, but there were 2 pages. And from them fault codes, you've got to work out like the starting point. there's no like magical way of putting them in any type of order. You can put them in order of occurrence or when they started and stuff like that. Environmental conditions you can look at. But concentrating on that Lin box, you just get a mechanic's hunch, don't you? I just thought, well, every time I erase the faults, the only one that stays is this one. I had no idea why it would. Now I know it's because every time you turn the key on and off, or turn it off and on, or should I say when ISTA erases the fault, it does a terminal change. The reason it kept coming back was quite straightforward in the end, wasn't it? Because that voltage, it will disappear slightly. But, when the key is off, there's 3 volts there. Still 3 volts there. And because there's 3 volts there, it's reporting a short. Even when the key terminal change is being performed, it can still monitor stuff and it's monitoring the short. I didn't know that at the time. Hindsight's a wonderful thing, isn't it? And all the time you've got other jobs backing up, which is why I made that decision to contact MSX International and get some help. But as you can see, it didn't work out, did it? The help wasn't forthcoming. And for me to contact technical support, I'll tell you straight, for me to contact technical support, it means I'm really stuck. It means I just can't solve it, and I can count on one hand, literally, in the last 10 years where I've had to use some sort of tech support, third-party service, because I just haven't got a clue. I just couldn't work the thing out, couldn't join the dots kind of thing, as they say. But once I found that errant voltage, I was laughing. It was just a case of back tracing it. And, the Schottky diode in hindsight was a pretty good idea, but it's like, it's the wrong thing to do, and it's kind of like you're putting a sticking plaster on something that's going to carry on bleeding because it really needs to be stitched, It's probably a bad choice of words in that sense, but, it's the same sort of thing. You can't really fix a problem by masking a problem kind of thing. You need to know the reason why, because if you should have 0 volts and you've got 3, Schottky diode's going to kind of temporarily stop it, but it didn't stop the engine from dying because the DME, as the car's driving and the ground's just getting worse and worse the longer you drive, the temperatures are rising in the engine bay, back of the block where it is, the ground is getting worse and worse, resistance is building up and the voltage is getting less and less, and it gets to, like I said, a critical threshold around 9 volts, and everything shuts down. I just couldn't understand what was going on, and looking back it was like dead simple, really simple. I should have just spotted it right away, but I didn't. But at least I couldn't understand like how everything was like a domino effect kind of thing, And if you've enjoyed this video presentation, it's a bit long, but there was a lot to cover. Subscribe to my YouTube channel and TikTok if you've got that. I've got a thriving community on both platforms, and everything's building up nicely on there. And you'll find a QR code in some paper handouts which you can find on the stand there. Just scan it with your mobile phone and it'll take you straight to both platforms if they're on your phone already installed, and you can join there and follow me in the future for plenty more videos like this. Thanks very much, and I'll hopefully see some of you soon.